Hey guys, and welcome to the first part of this Getting Started with Selenium WebDriver and JavaScript video series on the Lambda Test YouTube channel. My name is Ryan, and I'll be your host as we begin the journey into web automation with JavaScript. During this course, you will learn how to set up and write web automated tests in JavaScript using Selenium WebDriver. By the end, you will understand how you can utilize some of the awesome features of the Lambda Test platform to run your tests across multiple browsers and versions in the cloud. This first video will focus on getting everything set up so that in subsequent videos we can focus on writing our first Selenium WebDriver tests. So now, let's start with some introductions. Throughout this course, we will be using JavaScript as our language of choice. JavaScript is one of the most popular programming languages, especially for web development. It has also become a very popular choice for test automation, and has seen the spawn of a number of testing frameworks, libraries and tools, including Cypress, Puppeteer, Playwright, and of course, Selenium WebDriver. Selenium WebDriver is one of the most widely used tools for automating web-based applications. It provides us with a toolkit we can use to interact with a web application in much the same way a user would. For example, navigating to a page, entering text, clicking a button, and even selecting something from a menu. Selenium WebDriver can be used to build robust, reusable, automated tests, which can be run against multiple browsers. So now the introductions are out of the way, we can get things set up. Before we can set up our project, we first need to install Node.js. Node.js is a JavaScript runtime environment which allows us to execute JavaScript code outside of the browser. To download it, just navigate to the Node.js website and select the version relevant to the operating system you're using. I'm using macOS, so I would select the latest long-term support version here. Just click on it to begin the download. Once it's downloaded, you can follow the instructions to install. You may already have Node.js installed. To check, you can navigate to the terminal and enter node --v. This will work on both Windows and Mac. If the command returns a version, like here, then Node.js is installed. If you get an error, then you may need to complete the installation steps before trying again. Alongside Node.js, we also need to ensure npm is installed. npm, or Node Package Manager, is a mechanism for downloading and installing third-party packages into your project. Now, npm is usually downloaded with Node.js. To confirm it is installed, we can just navigate back to the terminal and type npm --v, and again we should get a version returned. Now that we've completed our prerequisites, we can set up our project. To do that, I'm going to open up a terminal and navigate to my desktop. Here I'm going to create a new directory called Selenium Demo, and I'm going to go straight into that. This will be the root folder of our project, and from here we can initiate a new npm project. To do that, we just enter npm init. Now this is going to create a package.json file for us, but first it needs some information to put in there. We can enter through each of these steps, which will just use the default value specified in the brackets. At the end, just click enter to confirm. Our package.json file has now been created, and it looks exactly like what you see on the screen now. Once we've installed Selenium WebDriver, we will return to this package.json file to see how it's changed. Now that we have our package.json set up, we can install packages into our project. As mentioned previously, npm is the mechanism for doing this. If I navigate to the npm website, I can search for node packages including Selenium WebDriver. Here you can see that each package has a description, along with instructions on how to use it, including code examples. It also provides us with the command that we need to run to install Selenium WebDriver into our project. So I can copy this now. This will automatically install the latest version of Selenium WebDriver. In this instance, it's version 4.0.0, which is currently in beta. If I navigate back to the terminal, we can paste our command in and hit enter to install Selenium WebDriver. This won't take very long. Now that Selenium WebDriver is installed, we can go back to our packages.json file. Here you can see that we now have a new dependency, Selenium WebDriver. This now shows that Selenium has been installed into our project. In the final section of this video, we will be setting up the browser drivers. Drivers are used to launch a browser instance in our tests. To download a driver, we can navigate back to our npm page. On the Selenium WebDriver page, you will see a list of all the relevant drivers. For the purpose of this test, I'll be using the 𝗩𝗗𝗘𝗢 driver for Firefox, but you can use any of them. Be sure that you have the browser installed on your system as well. To download the driver, click on the link and locate the driver required for your operating system. I'm using Mac, so I will download this one here. Once downloaded, you can open up the driver and copy it to a location of your choice. I'm copying mine to a drivers directory on my desktop. Now that we've saved this file, we can update the system with the path. To do this on Windows, you can search for environment variables on the start menu. From there, you'll be able to find the path, which you can then update. On Mac, we can navigate to the terminal and enter sudo nano/etc/paths. You'll need to enter your system password, and this will show you the current paths file. To update it, we can just add a new line with the path to the driver. So in my instance, it's users. To exit, Control X, Y to save, and Enter to close. To confirm that that path has been added, we can open up a new shell and type echo $path. You can see that my new path has been added here. So that concludes the first video in this series. we now have everything set up that we need to write our first Selenium test, which we'll be doing in the next video. If you have any questions, you can find me on Twitter at RyanTestStuff, or you can contact Lambda Test directly at Lambda Test. You can also find more cool content from Lambda Test at the following addresses. Thank you very much for watching, and I'll catch you on the next video. Hi guys, and welcome to part 2 of this video series on Selenium WebDriver with JavaScript on the Lambda Test YouTube channel. During this session, I will be helping you write your first Selenium WebDriver test using JavaScript. So in part 1 of this video series, we focused on getting everything set up to allow us to write our test. So we've installed Node.js, we've downloaded Selenium WebDriver package, and we've set up our project. During this video, we're going to focus on writing our first test. First up, we're going to look at selecting an IDE. Then we can begin creating our test line by line to see how it works. During this part, we'll also look at the use of locators to find elements on a page. Once we've completed our test, we will run it locally and analyze the results. And then finally, we'll do a full review of everything we've achieved in this session. So let's begin by selecting an IDE. For the duration of this video series, I will be using Visual Studio Code, a free IDE which you can download on Mac or Windows. If you don't want to use VS Code, you're more than welcome to follow along in any other IDE you'd like to use. Just be aware that some of the buttons and actions might be a bit different on your IDE. So now that we've selected an IDE, we can get to the fun bit and write some code. So I'm going to jump straight into Visual Studio Code here. And I've actually already opened up the project that we created in the previous lesson, our Selenium demo project. And if I expand this, you can see we have our package.json file that we went through in the and we also have this directory here which contain all of our npm packages. So the first thing I'm going to do is create a new directory on the root of our folder. I'm going to call it tests. And as you can imagine, this is where all of our test files will go. Now from here, I'm going to create a new file which I will call first test.js.js, meaning it's a JavaScript file. Just enter to create that. So now we have our blank.js file where we can start writing our test. So as we write our test, I'm going to assume you have a little bit of JavaScript knowledge. So the terms variable and function mean something to you. You don't have to understand everything, but a little bit of understanding will go a long way as we write this test. The first thing we need to do is add a requirement statement at the top of our file. The required statement allows us to pull in specific functionality from a node module into our test. We'll be using Selenium WebDriver, so we'll need to require this node module in our test in order to use the Selenium WebDriver keywords. For us, we need to enter const curly braces builder equals require brackets, and inside quotation marks we can add our node module, Selenium WebDriver. And let's just finish with a semicolon. Great, that's our first line of code written. Next up, we need to create a function. A function will be used to house all of our test code. That means that when we execute the function, our test will run. In order to create our function, we will use the keyword async, followed by function, and now we need to give our function a name. In this instance, we'll just call it example. We can follow that up with an open and close brackets, followed by open and closed curly braces. Now our code will sit between these curly braces, so we can expand this out a bit. Now that we've got our function, we can start writing our code to navigate to an application. But first, we need an application to navigate to. In this demo, we'll be using the Lambda test sample to do site. This allows us to add new to-dos to this list. During this test, we'll navigate to this page and add a new to-do before closing the page again. So let's write the code now. So back we go to VS Code in order to write these steps. Before we write any code, I'm just going to add some comments so we know exactly what steps we need to do. So first, we know we need to launch the browser. Then we need to navigate to our application. And for the purpose of this test, we need to add a to-do. And at the end, we will close the browser. Perfect. So during this demo, we will write the code for each one of these steps. So let's start by launching the browser. We do that by using the builder command that we required at the top of our file. So I will write let driver, so this is our variable name, equals await new builder, brackets, and now we need to specify which browser we're going to use. So I will do for browser and then open a bracket, and in here within quotation marks we specify our browser. So in this demo we will be using Firefox. We downloaded the Firefox driver in the previous session, so that should all be set up. And then finally we can add build brackets and a semicolon at the end. Up, we can navigate to our application for this step here. To do that, we can use driver that we stored as a variable. So I'll do await driver dot get, and again open brackets, within quotation marks we can specify the endpoint that we want to navigate to. If I go back to this page here, this is our endpoint, so I'll just copy this, go back to our test and paste it in. So now we have our endpoint that we wish to navigate to. So at this point, if we wanted to see what was happening, we could actually run this. To do so, we need to call this function. So at the end of our file, I will add example, which is the name of our function. So at this point, if we wanted to see what was happening, we could actually run this. To do so, we need to call this function. So at the end of our file, I will add example, which is the name of our function, and then just open and closed brackets. So this line here will actually call our function, and that will in turn execute these steps. Now what we're expecting to see at the moment is a new instance of Firefox launch and navigate to this endpoint here. To run this, we can go to the terminal, open up a new terminal, and we can just enter node and then the name of our file, including the directory. So in this instance, we have node tests / firsttest.js. So if I run this now, you should see that a new Firefox browser is launched and it's navigated to our application. Perfect. So I will go back to our test. Okay. Now we can add a to-do. So if I go back to our application, you can see that in order to add a to-do, we need to be able to enter some text into this field here. So now we will look at how we can interact with this field to add a new to-do. Locators are an integral part of automating web applications. Using locators enables us to find and interact with web elements upon a web page. In our example, we want to be able to find this text field here so that we can add a new to-do. In order to find a way that we can locate this element, we can right-click and select Inspect. This brings up the inspector window. From here, we can find a unique way of locating this element. I could right-click on here, select Copy and XPath to select the XPath to this element. But in this instance, I'm going to use the ID field here instead. So the ID for this element is sample to do text. So we can use this in our test to locate this field so we can enter the text. So let's do that now. We'll jump back to Visual Studio Code, and under our Add to Do section, we will write our next line of code. So just like before, we start with await driver, but now we want to find the element. So we will use dot find element, and as I mentioned, we'll be using ID. So we open brackets by dot ID and open brackets again, and here we can enter the text of the ID that we want to find inside quotation marks. So if we go back to our web application, we want to use this sample to do text. So I'll copy that in here. I will paste that. So this will find the element which has the ID sample to do text. Once we've entered the text, we need to be able to submit it so it's added as a new to do. So if we go back to our application, we could interact with this button here in order to add our new to do, or we could simply press the enter key. And we'll be using the enter key to submit our new to do. So if I go back to my test, we can go back inside these brackets, add a comma, and we're going to use the Selenium keyword of key, followed by a dot, and followed by the key that we want to use. So we want to use the key return, all in capitals, and then I'll just add a semicolon at the end. Now at this point, our test is actually going to fail. And the reason is we're using two key words here in this line of code. which we need to require from Selenium WebDriver. The by and key. So in order to require them, we can add them to this constant here. So in here, we can just do comma by and then comma key. Perfect. Now they have been added into our file, we should be able to run this. So if I save my file, go back to our terminal and use the same command, node test/firsttest.js, hit run now, and we should see that a new Firefox browser opens up and our text is added to the field. So now we just have one line left to write in our test. It's always best practice to close the browser down once your test is finished. So we'll write a line of code now to close the browser. All we need to do is use await driver like we've previously used, and this time we're going to use .quit, just like that. So this will quit the browser once it's completed the steps above. So if I save this and run now, using the same command in the terminal, you'll see that a new instance of Firefox is launched. We navigate to the web page and the browser is closed. Now, every time we've run our test so far, we've used the terminal to trigger it. So we've used this node command followed by the path to the file we'd like to execute. I just wanted to draw your attention to the run button in Visual Studio Code. Now, most other IDEs will have an equivalent button, so have a look, you'll be able to find it somewhere. Up here, we have a play button, and that allows us to execute the code outside of the terminal. By pressing play, it will execute the test just in the same way as we saw using the terminal. If you're using VS Code and you don't see this icon, you may need to navigate to this extensions icon here in the menu and then search for Code Runner. And then you'll be able to install Code Runner, which will enable this button. So if I press this button now to run my test, you'll see that the output screen down here has started running our test, and shortly we should see a Firefox browser open and our test is getting executed. Great job! So we now have a test that we can execute using Selenium WebDriver and JavaScript. Let's take a quick look at everything we've achieved in this session. So, we've learned how to require the Selenium WebDriver node module into our test file. We've also learned how we can create a new asynchronous function and give it a name. Once we created our function, we were then able to write our code for our test inside of the function. First, we built a new browser instance for Firefox. Secondly, we navigated to our web application using driver.get. Once we were on our web application, we could use the find element by ID to locate the text box and add our new to-do, learn Selenium. We also saw how we could use key.return to mimic pressing the return key on your keyboard. Then lastly, we used driver.quit to close the browser. We called our function by adding this example down here. Once we completed our test, we learned how we could execute this test either via the terminal or via the run code option in our IDE. So that wraps up part 2 of this video series on Selenium WebDriver and JavaScript. If you have any questions, you can reach out to me on Twitter using the handle @RyanTestStuff, or you can contact Lambda Test directly. If you've enjoyed this video, be sure to check out the other videos on the Lambda Test YouTube channel. Alternatively, you can go to the Lambda Test blog and find many articles about a range of testing topics, including automation testing using Selenium WebDriver and JavaScript. Be sure to check out the certifications page on the Lambda Test website so you can learn how to earn your Lambda Test Selenium certification. Thank you very much for watching, and I'll catch you on the next video. Hi guys, and welcome to part 3 of this Selenium WebDriver with JavaScript video series on the Lambda Test YouTube channel. My name is Ryan, and today we're going to be talking all about assertions. First up, we're going to look at what we really mean by assertions, what they are, how and when we can use them. Secondly, we're going to look at 2 separate ways we can write our assertions. First up, we'll look at using the built-in Node.js library for creating assertions. And after that, we'll look at using 𝗙𝗓, an assertion library popular in Node.js. Finally, we'll do a recap of everything we've learned about assertions. Assertions are a mechanism for us to be able to validate the state of our application. For example, you could use an assertion statement to check that a URL has changed following a successful login, or perhaps the valid error message or alert pop-up appears in a certain situation. You could use it to check that an item has been successfully added to a shopping cart. In our example, we could use an assertion statement to check that our new to-do has been added to the list and contains the correct text. Assertions can be used to confirm if a test passes or fails. If our to-do hasn't been added or the text is incorrect, then our test will fail. If the to-do has been added and the text is as we expect, then our test will then pass. First up, we're going to take a look at the built-in Node.js package for writing assertions. Now, by built-in, what I mean is that we don't have to use npm to install this package in order for us to use it. However, we do still have to use require in order to use it in our test. So if I jump into Visual Studio Code and go back to the text we wrote in part 2 of this video series, I can add a new require statement under our previous one for Selenium WebDriver. So I'll start by using const, and then I'll call this assert equals require brackets quotation marks, and in here we are going to use assert, just like that. So now we've required this package in our file. So now let's take a look at what we'd like to assert. In our example, we were adding a to-do to this web application. And we added a new to-do called Learn Selenium. So what we want to do in this example is write an assertion to check that Learn Selenium has been added to our list. And to do that, we can go back to Visual Studio Code and start writing our assertion until we've created it. So our assertion will have to go below this line here. So underneath here, I'm going to create a new section called assert. And then in this section, we can start writing our first assertion. To begin with, I'm going to create a new variable called toDoText. This variable will hold the text we want to validate. So what we want to do is check that the newly created to-do contains the text Learn Selenium, which we used here when creating our to-do. In order to create our to-do, we need to be able to first find the element, much like we did when creating the to-do here. So we'll use await driver dot find element by dot. Now in this example we used ID, but for this line we're actually going to use XPath instead, like that. Add some brackets. Then inside these quotation marks we can add our XPath. In order to find an XPath we can use, I'm going to go back to our application, open up Developer Tools, and from here you can see that each of these to-do belongs to a single list. Every time a to-do is added, it gets inserted at the bottom of the list. So here is our latest to-do, and it's been added right at the bottom of the list. So our XPath in our test needs to be able to retrieve the last entry within this list. And to do that, we can go back to Visual Studio Code, and inside our quotations we can build our XPath. First we'll do // followed by li for list, and then we're going to open and close square brackets, and inside these square brackets we can enter last and then open and closed brackets. Now this XPath will find the list element and then retrieve the last item in it. We've only got one list on our page, so this will work perfectly fine. Now in particular, it's the text of this element we want to find. So to do that, we can use Selenium get text command like that. Just remove the extra weight. There we go. So now that what we're saying is find this element, the last element in this list, and retrieve the text value of that element. Then it will be stored in this toDoText variable for us to use in our assertion. Now in order to use the value retrieved by getText, we need to return it as part of a then function. To do that, after getText, we will type dot then, and then open brackets. Inside here we'll create a new function, and open brackets again, and in these brackets we'll just enter the word value, and then outside of these brackets we'll create new curly brackets, and then let's just create some space here. Now inside here we just need to do one thing. We can return value, just like that. And what this will do is return the value retrieved from getText and store it in to-do.txt. That means we'll then be able to use that value in our next line of code. So underneath here, we're going to write our assertion. To do that, we're going to enter assert dot, and we're going to use strict equal. And this is a mechanism for checking that two strings match. From here, we can open brackets. We need to provide two arguments. Firstly, what the actual value is, and then secondly, what our expected value is. So our actual example has been stored in this to-do.txt variable. So we've gone to our web application, we've retrieved the value, and we've stored it in to-do.txt. So our actual value, we can just type to-do.txt. Our expected value is what we've listed here, learn Selenium. So we can just take this string and add it here, like this. So what we're doing now is we're saying, check that the value stored in this variable, the value which is on our web application, check it matches the value here, learn Selenium. So now we can actually run this test to see if it works. Let's run it now. We can see from the output that this is now running. So any second now we should see a new instance of Firefox open, and our test runs. I'll go back to Visual Studio Code. You can see that the test has worked. We've got no errors. We have exit code equals 0, which means no errors, and the test is passed. If I change this text to learn JavaScript and saved it and rerun the test, you should now see Firefox open again. Our test gets run, but the browser doesn't close. And the reason it doesn't close is because our test has failed before our driver.quit step. And if we look at the terminal now, you can see that we've got an assertion error. Our actual value is different to our expected value. So this is how we can use assertions to check that our application is behaving in the way that we would expect it to. So now that we've had a look at using the built-in Node.js library for assertions, let's have a look at 𝗙. So 𝗙 is a very popular assertion library for JavaScript, and it provides us with three functions for writing assertions. We can write should, expect, and assert style assertions. Now each comes with its own syntax, but you can use whichever best suits your use case. For our demo, we're going to take a look at should. But first, let's install 𝗙. So I'll go back to Visual Studio Code, and from the terminal, I'm just going to do npm install 𝗙. So this is going to install the 𝗙 package into our project. If we open up our package.json file now, you'll see that we have Selenium WebDriver that we installed previously, but we also now have 𝗙 listed as one of our dependencies, which means this is now being installed into our package. Let's close that down. So now we can start using 𝗙 in our test. So as always, if we want to use a package in our file, we first need to add it at the top of our file as a require statement. So we'll do that now. var should, because we're using the should style of assertion, equals require, brackets, inside quotations, we can add 𝗙. Now in this instance, at the end of this line, we're going to add dot should and open and close brackets. Now if you're going to be using the expect or assert style of assertions from 𝗙, then you don't need to add this last bit. It's only relevant if you're going to be using the should style. So now that we've added this line in here, we can write our assertion. So down here we already have our previous assertion. So I'm just going to give that a little title here so we know what it is. So this is assert using node assertions, and then below that we can add a new one which says assert using 𝗙 should, and we can add our 𝗙 assertion here. Now one of the reasons that 𝗙 assertions are so popular is because they make those assertions more human readable, and you'll see that in this example here. When we're using should, we'd start with the value that we want to validate. So in this instance, it's our to-do text value here. So what we're really saying is to-do text should equal learn Selenium. And that's exactly how we write it. So we start to-do text dot should dot equal, and inside these brackets we can add our expected value. So in this instance it's our learn Selenium value here. So I'll just copy that and add that here. So there we are. This is our 𝗙 assertion. Our to-do value should equal our expected value here. So let's run this now. Before we run this, I'm just going to comment out our previous assertion, save the file, and then hit run. And we should see much the same as before. Our browser launches, the test runs, and the browser closes. When I go back to Visual Studio Code, I can see that our test is completed with a code of 0, meaning that there have been no errors. Likewise, if I change this to JavaScript, run it again, our browser will launch, but in this time it won't close because we received the error before we hit this driver.quit statement. There we are, the browser hasn't closed. If I navigate back now, you can see that in our output we've got an error, and we can see that we expected learn Selenium, which is our actual value, to equal learn JavaScript, which is our expected value. So let's have a look at what we learned today. So first up, we used a different way of locating elements on a page. Previously we'd used ID, but in this example we used XPath. We then had a look at how we could use the getText function to retrieve the text from this element. We then used .then to return that value and store it in our variable. Now don't worry too much about this. We're going to cover it in more detail on a subsequent video. Once we've stored our variable, we could use it in our assertions. Now we've used two different styles of assertions. First up, we use the built-in Node.js assertion to validate that the value of the to-do matched the value we expected. Secondly, we had a look at using 𝗙 to write our assertions using the should style. Again, we validated that our to-do, which was created, contained the text learn Selenium part. So that concludes part 3 of this video series, where we learned all about assertions. As always, if you have any questions or want to get in contact with me, you can use the Twitter handle RyanTestStuff to find me. Alternatively, you can contact 𝗩𝗚𝗄𝗡 Test directly. If you enjoyed this video, why not go ahead and check out the other videos on the 𝗩𝗚𝗄𝗡 Test YouTube channel. Alternatively, visit the 𝗩𝗚𝗄𝗡 Test blog, where you will find a range of blog posts about various testing topics. If you're interested in certifications, visit the certification section of the 𝗩𝗚𝗄𝗡 Test website, where you can learn how to get 𝗩𝗚𝗄𝗡 Test Selenium certified. Well, that's it from me, and I'll see you on the next video. Hi guys, welcome to part 4 of this Selenium WebDriver with JavaScript video series on the 𝗩𝗚𝗄𝗡 Test YouTube channel. I'm Ryan, and during this video we're going to be talking all about test frameworks. First up, we'll do a brief introduction to test frameworks so we can understand what they are and why we use them. Secondly, we'll take a look at one of JavaScript's most popular test frameworks, Mocha. Once we understand Mocha, we'll look at how we can add this test framework into our existing Selenium WebDriver test. Once we've added Mocha, we'll understand how we can run our test using the test framework. And finally, as usual, we'll do a full review of everything we've looked at during this video. So let's get started. Every scripting language comes with a number of different frameworks to select from. Popular JavaScript frameworks include Jasmine, Jest, and Mocha. Now, every framework may use a slightly different syntax, and each come with a varying set of tools you can utilize within your test automation. Be sure to compare all of the test frameworks and select the one which best suits your use case. During this demo, we will be using Mocha as our test framework. So let's learn a little bit more about Mocha now. As mentioned, Mocha is one of the most popular JavaScript frameworks. It's open source and provides a whole host of features that make it a great choice for integrating with Selenium WebDriver. For example, it includes test parallelization, support for test retries, as well as test reporting. Mocha provides us with two core functions that we can use when writing our tests. First up, we have the describe function. Now, the describe function or block can be used to group tests together. So, for instance, in our example, we could have a describe block which holds all of our tests which add a to-do to our application. Next up, we have the it function. Now, it represents an individual test. So each of our Selenium tests will have their own it block. It functions sit inside the describe function, and a describe function could have multiple it functions inside. Now we're going to go ahead and implement this syntax in our existing Selenium test. So now that we know a little bit more about Mocha, I think it's about time we start writing some code. So I'm going to jump back to Visual Studio Code where we have our tests that we've been writing in the previous videos. Now, as always, to use Mocha, we first need to install it. So I'm just going to open up a new terminal and just do npm install Mocha. And this is going to install Mocha into our project. There we go. So now we have Mocha installed, we can start writing some code. First of all, I'm just going to add a little bit of space up here for us to work in. And we can begin by creating our two blocks. First up, we need to create a describe block. And then after that, we're going to create our it block. So to create our describe block, we first need to use describe as a keyword, and then inside the brackets, we need to provide two arguments. First of all, we need to provide a title, and then we provide a function. So our title should be something meaningful. So inside this describe block, we will have our test to add to do. So our describe title could be something like add to do tests, and then after that we can add our function just like this. And there we go, this is our describe block. And as I mentioned, our it blocks sit inside of our describe block, right in here. To write our it block, we use the same syntax, but this time we're going to use an asynchronous function because we're going to be executing some asynchronous code. So we'll use it as the keyword, open brackets. Again, we need to give it a title. So this is going to be our to-do test. So our title could be something like it. So successfully add a to-do to application, and then afterwards we're going to add our async function like this. There we are. So we now have a describe block, and inside that describe block we have a single it block. Now a describe block could have many it blocks inside. We've only got one test at the moment, so we just need one. So now we've done that, we can start moving our code here for our test. into the relevant blocks up here. Before we do that, we just need to do a little bit of tidying up first. So now we're going to be using Mocha as our test runner. We no longer need to execute the function using this example here. So I can remove that. And actually, we're not going to be using a function at all. I don't even need this function here. So we'll get rid of the curly bracket down here as well. So we now just left with our test code. Lastly, we currently have two assertions doing practically the same thing. One using the node assertion library, one using 𝗙. So we don't need both of these. So I'm just going to remove the one using node. If you want to remove the one using 𝗙 and keep the node one, you're more than welcome to do so. Now that I've removed the node assertion, I no longer need the require statement for this either. So I'm just going to get rid of this one as well. And there we go. We're now left with just the steps we need, and we can start moving them into our code blocks up here. So the simplest way to do this is to copy all of these steps and paste them directly into our it block here. Now this will work, and this is how we're going to run this test in this video. But in the next video, we're going to learn how we can split some of this code up into separate blocks to make it a little bit easier to read and allow us to reuse some of that code in subsequent tests. But before we do that, we can run this test and see how it works. I'm just going to use this formatter to reformat the code so it looks a bit nicer. And now we can run this test. During our previous videos, we've had to call the example function directly in order to execute our test. But now we've updated our test to use Mocha. During our previous videos, we've had to call the example function in order to execute our test. But now we've updated our test to use Mocha. In our previous videos, we've had to call the example function in order to execute our test. But now that we've updated our test to use Mocha, we can run it by invoking Mocha via the terminal. To do that, we use npx, which is the node package runner, and then we specify the package we want to run. In this instance, it's Mocha. Now, because we're using asynchronous code, I'm going to add a flag here for no timeouts. Mocha has a default timeout of 2 seconds, so by adding this, we just ensure that our test runs without timing out. Next, I'm going to add the path of where our file is. So our test file sits in a tests directory, and I want Mocha to find any files in this test directory which have the file extension .js. So I'll use the star for wildcard.js. Now Mocha will know to look in the test directory and pick up any files with the .js extension and run those. So I press enter now. You should see that it's found 𝗩𝗛𝗗𝗢, which is the describe title. And it's now launching the browser and running our test. Unlike previously, we now get a report which tells us how many tests have passed. So we only have one test, and thankfully it's passed. Now, by default, Mocha actually looks for a directory called test. Now, by default, Mocha actually looks for a directory called test within the project, and it will find any Mocha tests inside of that directory. So to make our command even more simple, we can rename our directory to test. That way, when we run our command via the terminal, we no longer need to specify the path to our test directory. When I run now, it's still able to pick up the 𝗩𝗛𝗗𝗢 describe block and is able to execute the test. To make things even easier for us, we can update our package.json file with this command. All we need to do is open up our package.json file and update the value for test. Notice we don't need to include npx, so it's just Mocha followed by any flags. So if I save this now, if we run via the terminal, instead of using npx, we're going to use npm for Node Package Manager. And instead of writing the Mocha command, we're just going to use test. You can see that this has actually pulled the command that we've added to our package.json file. It's located our to-do describe block, and it's executed our test. So I think we've achieved quite a lot during this video. So let's take a look back at our test and see what we did. So after we installed Mocha, we created this describe block, and inside that we created an it block. We then added all of our test code inside of this it block here. We then learned how we can execute our test using Mocha via the terminal, and also how we can update the package.json file to include our Mocha command. Now, in the next lesson, we're going to refactor some of this code to make it a little bit easier to read and make some of the steps reusable for other tests. So that's it for part 4 of this video series. As ever, if you want to get in contact, then you can find me on Twitter using the handle @RyanTestStuff. Alternatively, you can contact Lambda Test directly. If you like this video, be sure to check out the Lambda Test YouTube channel. There's plenty of other videos on there to view. Alternatively, have a look at the Lambda Test blog, where you'll find hundreds of blogs on various testing topics. If you're interested in learning more, check out the Lambda Test certifications page, where you can learn how to become Lambda Test Selenium certified. Anyway, that's it from me, and I'll catch you on the next video. Hey guys, and welcome to part 5 of this Selenium WebDriver with JavaScript video series on the Lambda Test YouTube channel. My name is Ryan, and during this session we're going to be exploring parallelization. First up, we're going to take a look at what we actually mean by parallelization, how that differs to how we've run our tests previously, and what the benefits of running our tests in parallel are. Once we've done that, we're going to add another test to our existing Selenium test suite. Of course, you can't run a single test in parallel, so we'll need to add at least one more. Once we've added our test, we'll then look at how we can use Mocha to run our tests in parallel. And of course, at the end, we will do a full recap of everything we've looked at during this session. So let's get started. First up, let's take a couple of minutes to understand what we really mean by test parallelization. So essentially, test parallelization is a way for us to run multiple tests at the same time. Now really there are two different ways we can run our tests, either serially or in parallel. When we run our tests serially, what we're doing is running each test in sequence one by one. That means that we're never running more than one test at the same time. The next test will wait for the previous one to finish before it begins executing. When we run our tests in parallel, it allows us to run multiple tests at the same time. So instead of just running a single test, we can actually run 2, 3, 4 tests at the same time. And the reason we do this is firstly to increase the execution speed of our test suite. As you can imagine, if we're executing more tests at the same time, the overall time it takes to execute a full test suite will be reduced. And as a result, this reduces the feedback loop. Testing is all about gathering information and feedback on our application. So if we can reduce the time it takes to gather all that information, it allows us to act upon that information earlier on in the process and hopefully fix those issues sooner. But test parallelization also comes with some complications. It's good practice to ensure that each of your tests is completely independent of all other tests in your test suite. It should not rely on the results of any other test or data created by any other test for it to run. You should be able to run each of your tests on its own without having to run a different test first. This means that when we run our tests in parallel, we know we don't have any data conflicts, and we know each test will be able to run regardless of which order it runs in. Secondly, we need to be conscious of the system that we're using to execute our tests. If we overload our system by running too many tests at the same time, it can actually have the adverse effect. We can start increasing the time it takes to execute our whole test suite. And we may see tests failing if we start overloading the system. So just be conscious that you're not running too many tests at the same time. And you can change the configuration and work out what the best config is for you to use to get the maximum speed out of your test suite. So now let's go and have a look at our tests. So up until now, we've just been using a single test in our Selenium test suite. But of course, you can't run a single test in parallel, so we're going to need to add another. If I go over to our test suite, we have our single test here in this first test.js file. Now, I mentioned previously that we can add extra tests within this file inside of our describe block. So we could add another it block to the end of this one with an additional test. But that is not how Mocha parallelization works. It won't run it blocks in parallel with each other. So if you have lots of tests inside this describe block, they still will run sequentially one after the other. Instead, Mocha runs these test specs or files in parallel. So if we were to create a new file with an additional test in, then we'll be able to see how Mocha will run those tests in parallel with each other. So we can do that now. So if I just copy what we already have, paste it here, and then rename it. Let's just call this second test. So we now have two tests, and at the moment they're doing exactly the same thing. But that's okay for this demo because it will just show how the tests run in parallel. We can look at adding subsequent tests which do different things later on. So the only thing I am going to change in this second test.js is I'm just going to change the describe block description and the it block description, just so we can differentiate between the two. So first up, let's change this to add another to-do tests and successfully add another to-do. Okay, so our tests are going to do exactly the same thing, but we should be able to see which one's running based on the description for the describe and the it block. So let's run that now via the terminal, exactly how we've run them previously. So we don't need to change anything, and Mocha will recognize that there's now two files in our test directory, and it should be able to pick up them both and run both tests. There we go, there's one done. You can see the Firefox is relaunched and it's now running the second test. If I go back to Visual Studio Code, you can see that it's ran add to do tests and add another to do test. So these are our two describe blocks, and inside each one has an it block which is run, and we have two passing tests, which is great. So now that we've run our tests serially, we can look at how we use Mocha to run those tests in parallel. And it's really simple to do. So if I jump back to the code, we've got our two tests that we've just run and both of them passed. And we saw how one instance of Firefox was launched and closed, and then once that closed, another one was launched and our second test ran, and then that closed. Now, in order to run both of these tests at the same time, we need to just update the command that we use to execute those tests. And if you can remember, that command is stored in our package.json file, and it's this script here. So at the moment, every time we run npm test, we're actually running Mocha with this no timeouts flag. So for running tests in parallel, we need to add a new flag. We can just add it to the end here. So just add a space, hyphen, hyphen, and then quite simply the flag is parallel. So using this flag will then tell Mocha to run our tests in parallel instead. So I can save this, and we can go back to our terminal, and we can now use exactly the same npm test command that we used previously, but this time instead of running Mocha no timeouts, it will run Mocha no timeouts with the parallel flag as well. And again, Mocha will know to pick up both test specs, both test files, but this time you can see that it's actually launched two instances of Firefox at the same time. So both my tests are running at the same time. I go, both closed. If I go back to Visual Studio, I can see, just like before, we have both tests which have been run, and 2 passing tests. The only difference this time is that we launched both of those tests at the same time and run them in parallel. So it's as simple as that, just adding a single flag to the end of our command in order to run them in parallel. So let's take a quick look at what we've done. So first up, we had to create a new file within our test directory, and this new file had a brand new test inside it. For this demo, it's exactly the same as our first test, but good enough to show parallelization. Once we'd added our second test, we updated our run command in our package.json file to include this Mocha parallel flag. And this tells Mocha to run our tests in parallel. Once we've done that, we could see that our tests ran exactly the same as when they ran sequentially, but this time they ran in parallel, both running at the same time. So that brings this short video on parallelization to a close. If you have any questions or want to get in touch, then you can find me on Twitter using the handle @RyanTestStuff, or you can contact Lambda Test directly. If you're interested to learn more, why not check out the Lambda Test blog, where you'll find a whole host of blogs about various testing topics. You can also check out the Lambda Test YouTube channel for other videos that you might be interested in. And lastly, remember that you can check out the certification section of the Lambda Test website to see how you can become Lambda Test Selenium certified. So that's it for this lesson. Thanks again, and I'll see you. Hey guys, welcome to part 6 of this Selenium WebDriver with JavaScript video series on the Lambda Test YouTube channel. My name is Ryan, and during this video we're going to focus on adding reporting into our existing Selenium WebDriver test project. Now, so far we've only been able to view results via the command line. So by the end of this session, we'll be able to view the passed and failed results of each of our tests via an HTML report. Now, to do this, we're going to be using a tool, a node package called Mochawesome. So to begin with, let's have a look at what Mochawesome is and how we can use that. Once we've understood that, we're going to add Mochawesome capabilities into our existing project, which is super simple to do. Once we've added those reports, we'll run our tests through again and we'll check the results, this time on the newly generated reports. And as ever, at the end, we'll just have a quick recap of everything that we've done during this video. So let's have a look at what Mochawesome is. Mochawesome is a node package which enables us to create custom reports specifically for the Mocha test framework. Now, we've already implemented Mocha in our existing Selenium WebDriver test, so we'll be able to utilize Mochawesome to generate some reports for our test execution. Now, so far when we've run our tests, we've only been able to view those results via the command line. Now, this isn't very pretty, nor is it easy to distribute those results to other team members or stakeholders. Using Mochawesome, we can generate prettier HTML reports, which can then be sent out to relevant parties to review. It can also make it a little bit easier to understand which tests have passed and which tests have failed. Now, we don't actually have to make any code changes to our existing tests in order to generate Mochawesome reports. What we do need to do is install it into our project and then update our test runner command in order to generate those Mochawesome reports. So let's do that now. So to add Mochawesome into our existing project, we just need to open that project up in our IDE, launch the terminal, and from here we can install it in the same way that we've installed other packages into our project, and that's by using npm install followed by the package name, like that, and this will install the package into our project. Now, as I mentioned previously, we don't actually need to make any code changes to our existing tests in order to start generating reports with Mochawesome. We do, however, need to update the flags in our test command when we execute our tests. So far what we do is we run Mocha and we use the parallel flag to indicate that we want to run our tests in parallel. So to start generating reports, we just need to add some additional flags to the end of this. So everything in there at the moment stays the same, but at the end I'm going to add a space, hyphen hyphen, then we'll add our first flag, which is reporter, like that, to indicate that we're going to be using a report generator, and then the name of that report generator. So we're using Mochawesome. So if we were running our tests in serial mode, then this would be sufficient enough for us to start generating reports. But because we're using this parallel flag to run our tests in parallel, we just need to add an additional flag. So once again, I'm just going to add a space, hyphen hyphen, and then require Mochawesome/register, like so. Now what this does is registers Mochawesome as a hook, which we need to do when running our tests in parallel. Now this is all documented in the Mochawesome documentation, so it's worth having a look through that documentation and understanding everything that's required in order to generate these reports. But for us, this is enough to start generating them now. So I'm going to save this and I'll close our package.json file down, and then we can open up the terminal once again and we can execute our tests. npm test, and let's run. So you can see now that this has picked up our new test command. So we've now got the reporter Mochawesome flag and our require flag for parallelization. There go our tests. They have completed. So if I go back to VS Code, you can see that we still get the terminal output for our tests. So we can still see that we've got 2 passing tests. But in addition, we now have a new directory which has been generated by Mochawesome. So in the next section, we'll look at what's actually in this directory. So we've run our tests and we've noticed that in our project we have a new directory, this Mochawesome-report directory. So if I expand this directory, you can see that we have an additional directory called assets here, along with 2 more files below. So inside assets, you'll see that there's a number of different files. Now we don't really need to worry about these. This is the information that Mochawesome needs in order to generate the reports. So we can minimize this and we can focus on the two files we are interested in, this .json file here and this .html file. So if I start with the .json file, you'll see that it contains the raw information relating to this particular test execution run. So for example, we can see the number of tests, importantly the number of passing tests, and things like the start and end time and overall duration. If I scroll down a bit, we can see the individual results for each run, and from here we can see things like the description and the it description that we've specified in our test files. We can see the name of the file which has been executed and particular information about this particular run, how long it took, whether it passed or failed, and so on. If I scroll down a bit, I can see the first test.js file here, which has also been executed. Now obviously we only have 2 tests, but if we had many more, they'd also be documented here as well. You can see which version of Mocha is used in your execution, and also any particular options used when generating the Mochawesome reports. Now again, this is really useful and can be used to integrate with, you know, CI/CD, or even used to generate your own custom reports. But if I close this down and navigate to this HTML file instead, we can actually see what the report looks like. So this is what Mochawesome has generated for us. You can see that it's split up our tests, and we can click on this to expand and actually see the test code that has been executed as part of this test. We can also see things like the time it took to execute that test. So I can also expand this one and see, we know in our instance these are the same at the moment, but again, if you had many different tests, you'd be able to see them all here. So we've seen what the Mochawesome report looks like when we have 2 successful tests. So let's have a look at what it looks like if we have a failed test. So back in VS Code, I'm just going to change our second test.js file, and I'm going to do 2 things. First of all, I'm going to add a new it block to our describe block. So this will be a brand new test, and I will call it adding a new test for reporting, just so we can see that it's different in the report. And then this one, I'm going to change the expected text to learn JavaScript. Now, because I've changed the expected test, this test is actually going to fail. So we should see the test in first test.js pass, one of the tests in second test.js pass, and the other one in that same file fail. So if I open up the terminal again and do npm test and execute our tests, so now we've got 3 tests which are going to run. We should see that reported on the terminal in a minute, and then we'll have a look at what it looks like in the Mochawesome report. So it's just running the final test now. This one's stopped because it's actually failed. So if I go over to Visual Studio Code, you can see that that test has failed. So we've got 2 passing and one failed as expected. So if I open up this directory again, these files get overwritten with each run, so these will be our new files. So we can open up this one in our browser and take a look at what it looks like now. So now we can see this add to dos test for our first test.js is completely unchanged, so it looks exactly the same as it did before. But in our second test.js file, we have our describe block, and inside that we have two tests now, including our adding a new test for reporting test, which as expected has failed. So again, we can have a look at the code which is actually executed, as well as the error that's returned that we've already seen in the terminal. So we've seen how Mochawesome generates custom reports out of the box for us, and we've seen how this Mochawesome-reports directory gets generated with the Mochawesome reports inside. But we may want to change this directory or even the file name to something a little bit more useful and meaningful to our project. And we can do that by updating our script that we use to run our tests. We can add additional flags in order to configure these sorts of things. So we can do that now. The first thing I'm going to do is add a new flag, as before, space hyphen hyphen, and this one's called reporter hyphen options. And from here we're going to add two new options to use. We're going to add one to change the directory that our reports go into, and then one to change the name of the files. So to change the directory, we can use report dir for report directory, and then we can specify the path to that directory. So say equals, and then if we just take the path from here, so instead of Mochawesome reports, let's change it to test reports. So our reports will get saved in a directory called test reports. And secondly, let's change the name of the files. At the moment it's just called Mochawesome, so let's change it to report file name, and again equals, and let's just call it test results, like that. Cool. So we've added our two new options, reporter options. First the report directory, and then the report file name. Now there are other options you can update, but for now we'll just use these two. So if I save my package.json file, and from the terminal let's run our tests again. So this is running. So our final test running now, which again will take a little bit longer because it's going to fail. I jump over to VS Code. You can see that we've now got a new directory called test reports, which is what we specified in our command here in our reporter options. And if I expand this, we have the same structure,
but this time our report's called test results instead of Mochawesome. So you can see how you can configure this to match what you require inside of your project. So now we've completed that, let's do a quick recap of what we've done during this video. So of course we first installed Mochawesome into our project, and then once we've done that we updated our script here to include this reporter flag specifying Mochawesome. We then added a second flag which was required for us to run our Mocha test in parallel. This require Mochawesome/register flag. Running our test suite using these two flags produced a Mochawesome-report directory with two Mochawesome reports, one in HTML format and the second in JSON format. Adding some additional reporter options then allowed us to configure the directory that those reports are stored in, as well as providing a custom file name. So now we get reports in a new directory specified by us, as well as reports with the desired name. We also reviewed the output of the Mochawesome report, so we could see what success scenarios and failure scenarios look like when they're output in the HTML report. So that's it for this video, where we learned how to implement Mochawesome reports into our Selenium test suite. If you have any questions about what we discussed in this video or any of the other videos in this series, then you can find me on Twitter using the handle @RyanTester, or you can contact Lambda Test directly. Be sure to check out the Lambda Test blog, where you will find various blogs on a number of testing topics, including how to implement Mochawesome reports into your Mocha tests. And of course, be sure to check out the certification section of the Lambda Test website, where you can learn how you can become Lambda Test Selenium certified. So that's it for this video. Thanks again for watching, and I'll see you on the next one. Hey guys, and welcome back to the Selenium WebDriver with JavaScript video series on the Lambda Test YouTube channel. My name is Ryan, and during this video we're going to be exploring how we can execute our Selenium WebDriver tests on Lambda Test's cloud-based Selenium grid. Now, before we update any of our tests, we'll first take a moment to introduce ourselves to Lambda Test and look at what the key features of Lambda Test are. Secondly, we'll explore some of the advantages of using Lambda Test. Then we'll have a look at the Lambda Test portal and understand where we can get our username and access key from. We'll need to add these to our tests in order to run them. Then we're going to look at how to set up our desired capabilities, including things like the browser and the browser version. After that, we'll be ready to update our tests and run them on Lambda Test. And of course, at the end, we'll do a full review of everything that we've achieved during this video. So let's get started and look at what Lambda Test is. So Lambda Test is a cloud-based platform that we can use to run our Selenium tests against multiple browsers and browser versions. So currently we've only been running our tests on our local machines by downloading the drivers to the particular browser we want to use, in our instance Firefox. With Lambda Test, we can instead select browsers and browser versions that we require, and execute our tests directly against them, instead of having to download multiple different browsers and browser versions on our local machines. The advantage of using the Lambda test platform is that by doing so, we won't have to maintain our own locally hosted Selenium grid. So as I mentioned, we're only using the Firefox browser in our tests so far. But imagine if you wanted to execute those tests against several different browsers and several different browser versions and operating systems as well. You can imagine that this will get quite complicated to maintain over time, ensuring you've got the latest drivers installed and multiple versions of the same browsers available to you. By using Lambda test, we can utilize the thousands of different browser version operating system combinations they have and just execute our tests against the versions that we need to. Now, in order to utilize Lambda test in our Selenium WebDriver tests, we'll need to add a username and an access key to our script. Before we can do that, you'll need to sign up to Lambda test. You can do that at 𝗩𝗛𝗗𝗢𝗏.com by either selecting the pricing item on the menu and then selecting the required plan, or you can use the start free testing option in the top right hand corner. Now, once you're signed up and logged in, you can access your account, and from your account you'll be able to see your username and your access key. If I click up here and then go to my profile, here you can see that I've got my username here and my access token, and you can just copy out both of these and use them in your tests. So along with the username and access key, which we've just retrieved, we'll also need to add a little bit more detail to our tests around which browsers and browser versions and operating systems we want to run those tests on when we execute them on the Lambda test platform. Now, the easy way to build those capabilities up is to use the Lambda test capability generator. So if you navigate to 𝗩𝗛𝗏.com/capabilities generator, you'll see this screen. And from here, you can define the capabilities that you want to use and get them in the exact format that your particular scripting language requires. So for example, in our test, we're using Selenium 4 and we are using JavaScript. So if I click here, it then returns everything that I'll need to add to my tests in order to run them on Lambda test with this browser. So you can see the selection at the moment is Windows 10, Chrome on version 19.2. But if I wanted to run this on a different version of Windows or even on Mac, I could do that. And then I could change the browser accordingly. So if I wanted to run it on Edge instead, and maybe I wanted to change the version, you can see that the capabilities here are updated based on what I've selected here. There are other specific things I can select as well if there are special requirements that I need in my test. But for now, let's go back to our configuration here and we'll select Windows 10, and this time we'll run it on Chrome. So far we've only run locally on Firefox, so we'll run on Chrome and we'll do the latest version of Chrome, the beta version. We've made sure we've got Selenium 4 selected because that's what we're using in our tests, and we've highlighted JavaScript here to get this in the right format. So we can copy this to clipboard and then we'll be able to use that in our tests. Now that we've got our desired capabilities from the capabilities generator, we can add those to our tests and configure our tests to run on Lambda test as opposed to running locally as they are now. So we're going to make a few changes to our tests. To start with, I'm going to add a brand new file, and let's call it capabilities.js JavaScript file, and it's in the root folder of our project. And we're just going to paste in the capabilities that we got from the capabilities generator, which has all the config we need to run on our chosen browser. In addition to what we've already got, I'm just going to change a couple of these values. So this build one, we'll just call it test build, and the name, we'll call it Selenium test. These values will make a little bit more sense in a minute. I've also got our username and access key, and obviously the browser and operating system details that we need to run our test. Cool. So in order to use these specified capabilities in our test files, we need to first export it from here, and then we can import it where we need it. To export, we can just use module.exports equals curly bracket, and then inside here we can add the name of our variable, so capabilities, just like that. So this then allows us to import it into our test files. So we're going to be working on our second test.js file. So if I open that up, and right at the top here under our require Selenium WebDriver, I'm going to add a new constant, and I'm going to call this one, just so we know what it is, I'll call it LT for Lambda test and capabilities. Okay, Lambda test capabilities equals require, and then we just need to specify the path to where we can find our capabilities.js file, which is ... to go upper directory, and if I put slash there, it automatically brings back the files and directories inside the root directory of our project. The one we're interested in is capabilities. Cool. So we've now required LT capabilities, our capabilities, into our test file, but we're not using them yet. In order to use them, we're going to write some more code under this describe block. So far in our describe block, we've only used additional it functions, but you can actually write information directly inside your describe. And the advantage of doing that is that it's then accessible by all of your it functions. So instead of specifying something individually in each it block, we can actually specify it directly in describe, and therefore we don't have to duplicate that information across multiple tests. Now we need to tell our tests how to connect to Lambda test. So far we've imported the capabilities, but we haven't told our tests how they can access the Lambda test Selenium grid. So we're going to do that now, and the information we need to include is username, key, and then a host. And then by combining these bits of information, we're going to create the URL that we can use to access the Lambda test platform. This isn't the URL to our application, which we have here. This is the URL to the Lambda test application. Now, username and key we already have. We've got them specified in our capabilities. So we can pull them out now. So constant, and we'll call this one username, all in caps. Now, this will be equal to LT capabilities dot capabilities dot the value for that particular capability, if I highlight this, is user dot user, like that. And then for our key, we can do a very similar thing. Let's copy that. This time we'll call it key, and this time it is called access key. So what we're just saying here is that set the value of username to the values stored in the user field of our capabilities file, and we're then doing the same for our access key. Now, the name of the host we can access from the Lambda test dashboard, but I've also got it here, so let me copy it over like so. We've got a new constant called grid host, and this holds our host for Lambda test. And we're then combining these three pieces of information to generate our grid host, which is made up of our username, our key, and our grid host. So now that we've specified this information, we can use it to build our driver instance. So far, when we've created our driver instance, we've done it using this line here, and we specified the browser we want to use when building our driver. And we've actually got this line specified in both of our it blocks, which isn't great for duplication. It means if our browser changes, we have to change it in two different places. So this time when we build our driver, we're going to do it slightly differently. We're going to be utilizing another Mocha function, this time called before each. Now, before each functions are really useful because they allow us to specify bits of code to be executed prior to each it block. So if we specify information in a before each block inside our describe, that before each function is going to be executed prior to every it block. So it's really great to add information without having to duplicate it across multiple it blocks. In order to create a before each, we can use the same syntax as we've used for describe and it, but this time we call it before each. We don't actually mean for this. The function like this. So we've got our before each block now, and it sits inside our describe block. Now, in here, we're going to build our driver instance. In order to do that, in our describe block, I'm just going to add a new variable called driver We don't need to specify a value because we're going to do that inside our before each block. So it's going to look a little bit like this. So I'll just copy that and add that here. We don't need the await keyword because we're not using a synchronous function. So we're going to do a driver new builder, and we no longer need to specify the for browser because we're doing that inside our capabilities instead. So we don't need to explicitly say it here. What we do need to add is using server. So new builder dot using server, and in here we need to specify the URL of the server, and that's our grid URL. So we can just add our grid URL instance there. And lastly, we need to use our pass in our capabilities as well, and we do that using with capabilities, and then inside here we're going to use LT capabilities, which we've required up here, and then it's LT capability dot capabilities. Now this is getting a little bit long, so I'm just going to add this to a new line. It's a little bit clearer what we're doing. So now, as before, we're building a new driver instance, but this time, instead of specifying for browser, we're specifying the use server here and passing in our grid URL for our Lambda test Selenium grid. And then we're also passing in our capabilities, which is where we're specifying the browser and browser version and operating system that we want to use. Cool. So now that we're doing that within our before each, we no longer need to do it in our it block. So I can comment out that there. And as I mentioned, this before each will get run before each of the it blocks. So I can comment it out here as well. So that's good so far. We're getting pretty close to being able to run our tests on Lambda test. I'll just save this. So there's one final thing that I want to do in order to tidy up this script a little bit more and get rid of some duplication. So I'm going to create inside my describe block, I'm going to create a new function. So I'll just copy this before each and paste it. But this time, instead of calling before each, we're going to call after each. Now, after each, as you probably guessed, is much the same as a before each function. It's part of the Mocha framework, but this time the code inside the after each function gets executed after each it block. And again, we can use it to allow us to add code in here that needs to be executed after each of our tests. That means we don't have to add it directly into each of the it blocks. So it's really good if there are cleanup tasks or teardown scripts that you need to run after each test to get ready for the next test. So in our tests at the moment, at the end of each one, we call this driver.quit method here in order to close the browser. And as I mentioned, we've got this in both of our tests here. So what we can do is add that to our after each block instead, and then we don't have to call it in both of our tests. So let's do that now. So if I remove that, and add that in here, I'm going to make this an async function, and we're simply just going to quit the driver as part of this after read. So we've removed it from this test, and we can also remove it from this test as well. I'll just save that. Okay, so now we've done everything we need to do in order to run our tests on Lambda test. The final thing I'm going to do is make this second test pass. So currently it fails because we are writing the phrase learn Selenium, but we're expecting it to be learn JavaScript. So I'm just going to copy this here and add it there, so our expected and actual text will match now, so both of these tests should pass. So if I save that. Now, to run our tests on Lambda tests, we use exactly the same method as we did when we were running them locally. We just use the terminal and call our npm test script. So if I open up a new terminal, and then from here we'll do npm test. Now it's worth noting that we haven't actually updated firsttest.js, so this test is still going to run on our local Firefox instance. So we should see one browser instance launch and run our firsttest.js, but we won't see the browser instances for secondtest.js because they'll be running on Lambda test instead. So if I run this now, we should see that our one Firefox instance gets launched, and that's our first test. But if we go back, we've already got 3 passing tests, but we only saw the Firefox instance launch for this test here. So to see what's actually happened, we can head over to the Lambda test dashboard and have a look. If I just refresh this now, you see on this recent test section we have 2 tests, and the build is called test build, and if you remember, that's what we had detailed as our test build in our capabilities. If I click on one of these, I can then get a little bit more detail. So you can see that I've got 2 tests here. Both of them are called Selenium test, so maybe we'll correct that in a minute to make it a little bit more useful. But both my tests have passed, and if I click on this one here, for example, I also get this video which I can play to see exactly what's going on. So that's my test to add learn Selenium, and I highlight this one, press play. This is my learn JavaScript test. So you can see that both of these tests have been executed on the Lambda test platform against the Chrome browser on Windows 10. So it's a little bit annoying that both of these tests have the same name. This is the name which actually comes from our capabilities file, but it doesn't make it very clear as to which test is which. So we can make a quick change to our script so that instead of returning this Selenium test name, it sets the name to the name of that particular it block. So for example, this here. It's super simple to do. All we're going to do in our before each block here, we're going to add a new line at the start, which will be lt capabilities dot name. So this is the file that we're requiring, followed by the name of the variable in that file, this capabilities, followed by the field we'd like to change, which is this name field. So lt_capabilities.capabilities.name equals this dot current test, which exposes some information about the test which is currently running, dot title. And in our example, the title will be the name of the it block. So if I save that now and rerun our tests, we can jump over to the Lambda test dashboard, and we can see we've got 2 new tests. So if I click on here, it displays them, and now we can see that we've got the more useful names based on the name of the it block. So that is it for this video, and we've finally been able to run our tests on the Lambda test platform, which is a really great achievement. So if you wanted to discuss anything or needed any clarifications, then you can get hold of me on Twitter using the handle @RyanTester. Alternatively, you can contact Lambda Test directly and they'll be able to answer your queries. If you've enjoyed this video and you want to learn a bit more, why not visit the Lambda Test blog, where there are literally hundreds of blog posts on various testing topics that may interest you. Also check out the Lambda Test YouTube channel, where you can see more of these videos, including a new video series on using Cypress with Lambda Test. If you're interested in certifications, visit the certification section of the Lambda Test website, where you can learn all about Selenium certifications. So that brings this video to an end. I want to thank you again for watching, and I'll see you on the next one. Hey guys, and welcome to part 8 of the Selenium WebDriver with JavaScript video series on the Lambda Test YouTube channel. My name is Ryan, and in this short video we're going to be looking at how we can run our tests in headless mode. Now this is kind of a continuation of what we've looked at in the previous video. So we've looked at how we can set up our tests in order to run them on the Lambda Test platform. Now we're going to be doing the same, but we're going to be adding a headless capability in order to run our tests in headless mode. Now, before we do that, we'll have a quick look at what we mean by headless testing and what the advantages of running our tests in headless mode are. Then, as I mentioned, we're going to be updating our capabilities that we added in the previous video to include headless. Once we've added that capability, we'll rerun our tests just like we did before, make sure they're still working, and then of course at the end we'll do a quick roundup of what we've done during this video. So let's get started and have a look at what we actually mean by headless mode and headless testing. So when we say headless testing, what we actually mean is running our UI tests on a headless browser. And a headless browser is simply a browser which doesn't have a graphical user interface or GUI, and therefore doesn't actually render the page visually for us to see. Now the advantage of this is that when we run our tests, we don't have to wait for everything to load up on that page in order to continue our tests. So there's lots that are going on behind the scenes to load all those images up and present that to the user. But when we run our tests headlessly, we don't need to worry about that. And that means our tests often run faster in a headless browser and are less flaky. There's less things that can go wrong, so they tend to be a little bit more robust as well. Now the trade-off is that nobody actually uses a headless browser to view a web application, because you won't see anything. So it's important to still test your application using the traditional browsers as well. Headless is not a complete replacement for the traditional browsers. but it is a great way to run your automated tests more robustly and quicker, and perhaps earlier on in the testing lifecycle as well, in order to find bugs. So in order to run our tests headlessly in our local system, we can pass in a headless option when we start building our browser instance. But we're not going to do that. We're going to be using the Lambda test platform to run our tests headlessly, and it's really simple to do. First up, we're going to have a look at the desired capabilities again. So we went through this in a little bit more detail when we built our capabilities for running our tests in the previous video. So we're not going to go through everything again, but I do want to draw your attention to one option. So if I just select JavaScript and Selenium 4, because that's what we're using. So previously we selected the relevant operating system and browser and version that we want to run against, and that's worked fine so far. But there are a whole host of other options that we can add to our desired capabilities. So if I have a look at this advanced configuration here, we can do things like turn on console output, and you can see that it adds a new value here to our capabilities. Change things like the time zone or add screenshots. For this video though, we're going to focus on a Chrome specific capability. So if I open this bit up here, you can see that I've got this headless option. And this is simply all we need in order to run our tests in headless. We need to add this headless value to our capabilities and ensure it is set to true. Now, headless isn't available on all browsers. So if I change my browser to Firefox, for example, you can see that we've got headless available here as well. But if I change my configuration to something like Mac and then pick Safari as our browser, if I have a look here, we don't actually have a headless option available to us when we're running our tests on Safari. So if I go back here and I've changed this back to what we had previously, which was Chrome, and set this to headless, so that gives me the option that I need. So now we can take this, because we've already got our capabilities set up, I can just take this single one that I need here, go over to our project, and in our capabilities.js file where we've stored our capabilities, I can just add another capability here. You go headless true. Make sure you've got the comma there. There we are. There we have it. So our capabilities have now been updated to include the headless true, the headless option here, which has been set to true. Now that we've set headless to true in our capabilities, we can run our tests in exactly the same way as we've run them previously. I am just going to change our build name in our capabilities, and this is just to make it clearer when we look at Lambda test which build is our headless build. So I'll change this to headless and save that, and I'll run them just by opening up a new terminal and using the npm test command and running this. So nothing else has changed here. We've still got 3 tests which will be run. One of them is going to execute locally, which is what's running now on Firefox, and the other 2, as per our previous videos, will run on the Lambda test platform. Now, of those 2 that run on Lambda test, we're expecting one of them to pass, but the second one we're expecting to fail, because we're writing Learn Selenium and then our validation is checking that that value is learned JavaScript. So we know that one fails, and I've kept it exactly the same so we can see that nothing else has changed. Even though we're running headlessly, our tests are still doing exactly the same validation as they were doing previously. So now we can jump over to the Lambda test dashboard. If I just give us a little refresh, we should hopefully see our new build here. Here we go. This is our headless build. So if we click on this, we can see we've got our two tests, both part of our headless build. Both have been run successfully, but you can see now that we haven't got the video output that we had previously, and this is because we've run our tests headlessly, and of course our website isn't getting rendered in any browser, so therefore it can't take a video of what we've actually done. But we can see from the test results that we've got exactly the same results as we did previously. So that about wraps up this short video. It's a really neat trick to be able to run our tests in headless mode very simply by just updating a config parameter in our capabilities. We haven't had to update any tests whatsoever. So all we did was in our capabilities.js file here, we added headless and set that to true. And then when we had a look at this in Lambda test, we could see that this was actually running headlessly and nothing else has changed at all. So thanks guys for watching this super quick video. If you had any questions or queries about what we did during this video, then you can get hold of me on Twitter using the handle @RyanTester, or of course you can contact Lambda Test directly. Should draw your attention to the Lambda Test blog, where there are various blog posts on JavaScript and other scripting languages as well. There's even some posts around how to run headless tests as well. So if you wanted to check out those as well, head to the Lambda Test blog, or you can check out the Lambda Test YouTube channel to find other video series, including a new one on running your Cypress tests on Lambda Test platform. If you're interested in getting yourself Selenium certified, then make sure you check out the certification section of the Lambda Test website, where you can read all about the certifications that Lambda Test offer. But for me, this is the end of this video. I'd like to thank you again for watching, and I look forward to exploring more about Selenium WebDriver and JavaScript on the next video. Hey guys, and welcome to part 9 of this Selenium WebDriver with JavaScript video series on the Lambda Test YouTube channel. My name is Ryan, and as ever, I will be guiding you through this video, which this time is all about parameterization. Now, during this session, we are going to first look at what we actually mean by parameterization and how it can be used to enhance our testing. Then we're going to look at creating a brand new test and adding some parameters to that test. Then of course we'll run that test on the Lambda Test platform, and finally at the end we'll do a full review of everything that we've been through during this video. So first up, what is parameterization? So parameterization or parameterized tests are a really neat trick to enable us to use a single test and run it multiple times, but for different data inputs. So in our current test suite, we have multiple tests to add different to-dos to our to-do application. Now they work perfectly fine, but there is a lot of duplication in that code. So we have two tests which are very, very similar. The only difference is the input text that we're using to add our to-do. It would be great if we could remove some of that duplication and just reuse the same test, but instead pass in multiple values to it. And we can do that using parameterization. The advantage, as I mentioned, is that we get rid of some of the duplicate code that we're using. And that means if that code changes in the future, we need to change it in fewer places. So it makes the whole test suite more maintainable. Now, the other place we can use it in our test suite is to parameterize the browsers that we're testing our application on. So when we're using the Lambda test platform, we've seen how we can use the capabilities to specify the browser and the operating system and the browser version and run our tests on that specific setup. Now, we could use parameterization to loop over our to-do test multiple times for different browsers, and therefore we don't have to run our test once and then change the capabilities and run it again. We can just allow those capabilities to be changed as our test is looped over multiple times. So in this video, we're going to look at how we can use Mocha to parameterize our test. So for the purposes of this video, we're actually going to create a brand new test in our project. So our first test.js and second test.js are going to stay as they are, and we won't touch them. Instead, we'll create a brand new .js file with a brand new test in. Now, there are multiple ways we can achieve parameterization using JavaScript and the Mocha framework. There's several different packages that we could install which allow us to utilize parameterization and additional functionality in order to enhance our tests. Now, in this video, I'm going to use a simple approach using Mocha and JavaScript only. I'm not going to be installing any additional third-party packages. So what we will use is this for each functionality, which will wrap around our it block. So it will wrap around our test. And basically what we'll be doing is saying that for each of our browser and version and operating system combinations, rerun this test. And we won't have to do any manual changes after we've run our test on a single browser. It will automatically just loop through and run that test for as many combinations as we specify. So to get started, we can actually create a brand new test file. Let's call it param_test.js, and that's inside our test directory. And we can actually take what we've already got in our second test.js, because that's got a lot of the configuration already in. So I'll paste everything into our param_test.js test file. And now we're actually going to run our parameterized test on just this first it block. So I'm actually going to remove this second one to make everything a little bit more simple. Let's get rid of that. Perfect. So we've just got one test in here at the moment. And secondly, I'm going to remove our before each block and our after each block as well. Now I'm going to add this functionality directly into our it block. And the reason is that we need to be able to update our LT capabilities file, our capabilities here, on the fly. And when we use the for each block that we're going to use in a minute, it gets a little bit confused with the before each blocks. And it doesn't update it in the way that we need it to update. So as I mentioned previously, there are other third-party packages that you can use to achieve similar results. But because we're using the for each functionality, it's easier and a simpler way of showing you how this works is to remove our before each and after each block for this test. So I'll add our before each functionality back into our it block here, and at the end of our test we'll quit the browser. I'll copy that. Paste that there. Okay, so we now no longer need to use our before each and after each block here. So we've got our test, which will build the driver instance using the capabilities and run our test and close the driver. So first up, we need to specify the browsers and browser versions that we want to run our test on. And I've already done this, so I'm going to paste it here directly into our describe block above and outside of our test. And basically what we have here is a JSON array which contains 3 objects, and each object contains a browser, a version, and an operating system combination. So you can see that we've got Chrome version 93, Firefox 91, and another Firefox instance on version 90, all using the Windows 10 operating system. So now we have this list, we need to tell our test to rerun for each object in this array. So we could have more objects in here if we wanted to. If we wanted to run it on additional browsers, we can add new ones into here at any time. Equally, we can remove them from here if we no longer need them. And our test will just loop over for each object in here. So in this instance, our test will run 3 times, once for each of these. Now, in order to run our test multiple times, we're going to utilize the for each functionality that we saw in the Mocha documentation a few minutes ago. So we'll just type browsers in reference to the browsers array here. Dot for each, and then sort of brackets, and then inside here we need to pass in the values that we want to use inside our test. So we want to use the browser version, and the operating system. So we can pass each of those in. Browser, comma, B version for browser version, and OS for operating system. And then this is a function. Let's do that and open up the curly braces. Okay, so this is our for each block, and this needs to wrap around our it block. So at the moment they're completely separate, so we can do one of 2 things. You can either copy all of the code from your it block inside of this for each block, or you can move these brackets here to the bottom of your test. like so. Make sure you delete them from here as well. So there we go. So now our it block is wrapped inside of our browser for each block here. So you can see that everything between these two is our test. So the final thing we need to do is to ensure that our test updates our capabilities before it builds the driver instance. So we've got our capabilities that we use to run our test on Lambda test. And inside of our test, we want to update the values, much like we do here. So if you remember previously, we're using this line of code here to update the capabilities name, this value here, to the name of our particular test. So we're going to do the same now, but update the values for browser, platform name, browser version, and browser name. So these three values here. So we'll use the same syntax as we've used here. If I make my screen a little bit bigger so we can see. So we'll do lt capabilities dot capabilities dot, and first of all we will do platform name, and then we'll say that equals the OS, and then we just need to do that 2 more times. Like so. And this second one becomes browser name. And then browser version. Browser name comes from this browser value here. And then browser version comes from this B version value here, which ultimately comes from this set of values here. Okay, so basically what we're saying here is that update the capabilities, the platform name in capabilities, to whatever OS version is passed in, depending on which values we're iterating through, and do the same for the browser name and the browser version. Just because we've moved this line inside of our it block, we also need to just change that. So just remove it from here and just delete that, and instead it becomes this test dot title instead of current test. Okay, so that's basically all we need to change. So we've got our list of browsers, we've added this for each function which wraps around our it block, and then when we go into the it block to run our test, before we build our new driver instance using these capabilities, we update the values here. So one other thing we could do is, just to make it a little bit clearer, we could actually change the name of our it block based on the values that we're passing in. So successfully adds a to do, for browser, and we can do $ and curly braces, and then here we can pass in the variable that we're using. So browser, and then let's do another one of those for browser version, and then one more for OS. So now that when we run this test, it's actually going to print out the values of the browser and the browser version and the operating system as part of the title of the test, which will make it clearer if one of those tests fails, and make it clearer actually where it has gone wrong and which browser it's running in that particular time. Perfect. So we can save this and then we can run it and see what it looks like. So now that we've created our new parameterized test, we can go ahead and run it, and we'll have a look what it looks like on the console, and also we'll go onto the Lambda test dashboard and have a look at the test there. So before I do that, if I just come over to my tests, and I'm actually going to switch headless to false, just so we can see what's going on when we get over to Lambda test. So I'll save that, and then I can open up a new terminal and we can go ahead and run this. So instead of running everything, I'll just run our new param test.js file. So to do that, we just use npm test again, but this time I'm going to pass in this particular file using the relative path to that. So that is test, because it's in our test directory, /param test.js. Let's run that. So it's going to run exactly the same command as we've run previously, but just for our param test.js file. And it will now be running on the Lambda test platform, and we should see the results of that printed in the console any second now. Perfect. So although we've only got one test inside our param test file, you can see that we've actually got 3 passing tests. And because we've updated the name to include the browser and the version and the operating system, you can see exactly what's run. So you can see that first it's run the test on Chrome, then it's run on Firefox version 91, and then on Firefox version 90. And thankfully, all 3 of those tests have passed. So if we head over to the Lambda test dashboard, you can have a look, and we should have some new tests here. So you can see that we've got one here for Firefox version 90, version 91, and then our Chrome version here. If I just drill down into one of these tests, we'll see the details. Here we go again, you can see what version everything's run on, and because we're not running headlessly, we've got the video as well, so we can see exactly what's going. You can see that's run on Firefox as opposed to this one here, which runs on the Chrome instance. So let's take a brief moment to review what we've done. We can basically split up the changes that we've made into 3 parts. Firstly, we added an array of all the different browser versions and operating systems that we wanted to run our test on. We added it directly to our describe block. Secondly, we added this for each function and wrapped it around our it block. So our it block, our test, sits inside this for each function, and in that for each function we passed in the values that we wanted to use. So it's basically saying for each browser and version and operating system in this list, I want you to run this test. And finally, we updated our test to set the capabilities for these values on the fly. So each time we run the test, we set the platform name and the browser name and the browser version based on the values that get passed in here. And then we build the new driver instance. So that is it for this video, where we've learned a neat little trick to parameterize your Mocha Selenium WebDriver test in JavaScript. Thank you for watching. If you have any queries or questions about what we've achieved in this video, then you can get in contact with me on Twitter using the handle 𝗩𝗚𝗗𝗢𝗏, or you can contact 𝗩𝗚𝗚𝗃𝗏 Test directly. Alternatively, leave a comment on the YouTube video and we'll get back to you with an answer. Now, if you're like me and want to learn more, then go and check out the 𝗩𝗚𝗚𝗃𝗏 Test blog, where there are new articles being added every week. There's so many different testing topics, including running Selenium WebDriver tests in JavaScript. If certifications is something you're interested in, then check out the 𝗩𝗚𝗚𝗃𝗏 Test website, where you can get a full list of the certifications that 𝗩𝗚𝗚𝗃𝗏 Test offer. Now that's it from me, so thanks again for watching this video, and of course I'll see you on the next one.